This video shows my implementation of a flipped class pedagogy for general chemistry using the Moodle platform. So here's an example of my course Moodle page for general chemistry. The beginning page just has information that's useful to the entire class, but scrolling down you can see how the flipped class pedagogy is implemented. So for any particular given week, I post weekly assignment sheets. These are essentially a checklist of what students need to be doing in preparation for each class day and each lab, so students can always stay on track. It tells them, for example, that before you come to class number 4, in this case it will be on Monday, they should click this link on Moodle to see what their assignments will be. So they go to that class on Moodle, and it shows them that for class meeting 4 they have some instructions. So I always have a brief introduction of text to explain what they're going to be learning about. I include learning objectives that are then tied to specific things that will occur on the assessments, on the tests. They are then advised to read a section of their textbook and to watch some corresponding videos that help them understand, in this case, the periodic table. So they're going to learn about a little bit about the history of the periodic table organization and structure that is congruent with what their textbook explains. Then they are told that they're going to learn some more about section 1.14 in their textbook, which they should read, and then we'll be doing an activity in class, in groups, where they can learn about that topic in more detail. Then they are directed to go to the Sapling Learning System to work some questions. So Sapling Learning is the online homework system that I use, but it is similar to many others. So at the Sapling system, they would then find the corresponding assignment and they would go to that assignment. And it brings them up questions that they then are asked to work. So in this case, they're asked to identify these elements based on their location in their periodic table, give the symbol, not the name. And so they will type into each one of these blanks the symbol, and then they can check their answer. If their answer is incorrect, they can go back and try again. So the point here is simply to check that they've learned a little bit, point out holes in their understanding, and they move on to another question. So these questions are intended to be answered prior to coming to class, and this counts kind of like participation points as a small percentage of their grade, so it's kind of low stakes work that they're doing. Then back on the assignment sheet on Moodle, each bullet point item is a to-do thing. Then they are supposed to make a list of 3 questions or insights that they have and upload those to Moodle. This is an attempt to help hold them responsible for having done the pre-class work, and also to help them to identify holes in their own understanding. So back at the top of the Moodle page, I have a link to instructions on what they are to do for these question and insights assignments. So they are directed to identify 3 items. They can be either a question, a murky point, an insight, something that they've discovered that they didn't know before, or if it's something that they already understand pretty well, what they think one of the key points is from this reading assignment. Then they submit those. They need to submit at least 3. They can include more. This is also a good way for me to get an understanding of where students in a particular class, since my class is large, are having problems, so that I can address some of those questions at the beginning of a class period. Then when students come to class, I will have a list of announcements. I will go through some of the questions that they had, maybe work some specific examples, and then we will dive into working problems cooperatively that will help them to develop and deepen their understanding. So for example, I might, using PowerPoint, ask them a question such as this. I have an audience response system, clickers, that the students use to click in their multiple choice answer. The audience response system that I use also allows them to type in numerical responses or even words or short text phrases using a QWERTY keyboard. So in this example, they were asked to understand something about the metric system, and you see that my students performed fairly well, with about 70% of them getting the correct answer, but there's still a fair number of them that had some misconceptions, not understanding that a nanometer is a very small part of a meter and not the other way around, but knowing that 10 to the power 9th might be involved in some way or another. And so then we would go through and talk about these in more detail to help clarify any misconceptions. This also provides students a good way of understanding where their weaknesses and understanding are and how they're performing well relative to the rest of the class. So if you're here and you answered choice A, you were 2% of the class, and that tells you, hey, maybe I'm not getting this as well as I should be and should investigate some resources from the rest of the class. The other kind of activity that we do in class are group worksheets and activities rather like this one. So a student will be given a copy of this. They will work together in small groups, submit their answers to a set of questions. In this case, they're going through and looking at different sources and sinks of greenhouse gases, and in the course of this, practicing balancing chemical reactions. They then submit their group answers, which I then look at and give them a group grade. So it's another opportunity for students to sort of participate, see what they do and don't understand, and work with their peers to deepen their understanding. After class then, students are encouraged to go back and read their notes, prepare for the next class, and work more challenging problems that are assigned associated with each textbook chapter to help deepen their understanding. So they would go to the Sapling Learning System, for example, and work problems from Chapter 1. These will be a larger number of problems that they will have to work, and these are typically more challenging. Again, they're encouraged to work with each other outside of class on these problems, and they have the opportunity to submit multiple answers and get hints with each question to help them answer this and test their understanding. These then form the basis of deepening their understanding that they'll need to perform well on the major course assessments that are given at the end of each chapter and the final exam. So that's how the flipped class approach works, generally speaking, in my general chemistry course.